Welcome to Haltech Elite NSP Training Part 46. In this training tutorial, we're going to take a look at setting up our spark timing tables for both naturally aspirated and forced induction examples, and then talking about the general process of tuning our spark timing. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at setting up our spark timing tables within our Haltech Elite systems with our NSP software. The last tutorial we focused on the basics, the fundamentals of spark timing, what the values in our table here represent, and why we're trying to dial them in to reach what's known as maximum brake torque. Now, we understand conceptually what's going on. What values do we actually place into the table that are going to be good starting points? That's going to be relative to what type of configuration we're tuning. Whether the engine's naturally aspirated or forced induction, the values that we place in here will be different. So let's jump in here. Let's first discuss a naturally aspirated engine. What we need to configure in terms of our brake points here for load and engine RPM, and then what values we place here in our table. There is a general rule of thumb we can apply to most any engine, regardless of whatever the compression ratio is going to be, regardless of whatever fuel type you're going to be tuning on. Naturally aspirated, you will find relatively similar values in the table. There is going to be a sweet spot or a window for spark timing values. Going too low, the engine's power and torque production will suffer. It'll feel sluggish, it won't feel smooth. Too high, you'll run into knocker pre-ignition. We could damage the engine from uncontrolled cylinder pressure, uncontrolled combustion. So we want to be specific with this. Now, when we're starting our tuning process, we're going to be going after dialing in our airflow and our fuel model first. Then we'll dial in our spark timing. So we kind of have an order of operation, so to speak here. We want to go and make sure our fueling is good, then we turn to our spark timing and dial it in. But we need to have conservative or safe spark timing values to begin with, so that we're able to then go after the fuel and airflow model, and then we come back to the spark timing and try to further optimize that. We're going to talk about optimizing our spark timing in another tutorial, specifically when we're looking at working with our knock sensors and our knock control, because that will tell us conclusively how far we can go with our spark timing relative to whatever the engine's compression ratio is going to be and the octane fuel that we're tuning on. But right now, this is just going to be strictly taking a look at configuration settings, how to set up the table, essentially how to create a base spark timing table. So our very first example here is going to be a naturally aspirated engine. What do we do in terms of our breakpoint scaling here for a naturally aspirated engine? And then ultimately, what do we place here in our spark timing table to have reasonable values, safe values that we can use to begin our calibration process? All right. The very first thing I want to talk about here before we jump into configuring our breakpoints is going to be setting our ignition load relative to the application that we're dealing with. So the ignition load is the same idea as we talked about here in our fueling or airflow modeling table. Fuel load. Fuel load is going to be set either based on map pressure, throttle position, engine pressure ratio, or air mass grams per cylinder. That would be for tuning in a math-based type of environment. So if we go back in here to spark, we need to set this based on what we're trying to tune. So let's jump in here and take a look at where we can configure the ignition load. Now what you'll notice is that essentially all the Haltech base maps for the ignition load will be set on map pressure. This is typically how we set up and scale and tune spark timing table, referencing manifold pressure here in our upper window or upper load index of our table. But we do have some other options. So if we go here to our navigation tree, let's jump here to main, and we jump into ignition tuning, we're going to find ignition load type. Here we can see map sensor is selected. We do have the option air mass per cylinder. That's if we're tuning with a mass airflow sensor and we don't have a map pressure sensor hooked up at all to our Elite box, which I highly recommend that you do even if you're tuning with a MAF. It gives you another point of reference in terms of load registration. So you can choose air mass per cylinder. You can choose throttle position. That would be a full or true alpha N style strategy, where if our fuel tuning, the table was set on alpha N, so we've talked about that, throttle position based, and then spark timing can be set on throttle position based. If we do that, we just need to make sure that the brake points are being rescaled properly for a full alpha N type of control, and then we see engine pressure ratio, that's map over baro or map over EMAP. That's that essentially efficiency ratio or engine efficiency ratio. It's a percentage, and it will be relative to map pressure or whatever the other scaling factor is going to be, baro or EMAP, and we've talked about that. When we're dealing with spark timing, 99.9% of the time, you'll be using map sensor as your option, as your load index to your table.
So we do have these other options here. I cannot recall the last time I've ever selected anything other than map sensor, just for a perspective sake here of deciding what you want to choose. Not saying that you can't use throttle position if you're full alpha N, but the map sensor generally will work as well. I don't find a huge advantage switching to throttle position or full alpha N. And then air mass per cylinder, I would personally recommend, if you're running a mass airflow sensor and you're doing that for your fuel and airflow model, I would personally recommend to just keep a map sensor on board, wired in, or using the onboard map pressure sensor for spark timing reference. I find it just easier to track things, easier to go about that, but air mass per cylinder is an option. Engine pressure ratio is, in my opinion, pretty irrelevant for dialing in spark timing. So map sensor is what I'm going to choose here, and that's what I'm going to go through the tutorial here, and assuming you're running map pressure, because that's going to apply to...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.